So my name is Andy Rivenis. I'm a product manager for database and memory. I also have with me Maria Colgan, SQL Maria, who also database and memory is near and dear to her heart as well. What I thought I'd do is I would show you how to configure the column store. And I have a 12.2 Oracle database, and it's already up and running. So you can see we have a roughly a 400 gigabyte SGA. But notice we don't have, it just looks like a normal database. So what I was going to do is show you how to actually set up the column store. It's actually very simple. So let's do show parameters. Whoops. Like the problem with this is it's not scripted, so you got to watch me type. But show parameters in memory. So these are the in-memory initialization parameters. In-memory size is the one we're actually interested in, and is really the only parameter that you have to change or set up to take advantage of database and memory. So database and memory first was introduced with 12.102, obviously part of 12.2. I think we might have a couple teasers for you about 18C, but it's all fully integrated into Oracle database, so that's all you have to do. You don't do anything different with the installation. You don't have to do any, all you have to do is have enough memory to support the column store. And so what I'm going to do is I'm actually going to go ahead and we'll just allocate some memory to the column store. So in-memory underscore size is the parameter we care about. Let's give it 200 gigabytes. And so initially when you allocate the column store, you do have to recycle or bring the database up and down and then back up again. Actually, starting in 12.2, you can actually resize and increase the size of the column store, but you still have to initially allocate it.
And Andy, is there anything I should be mindful of when I'm picking that size for the in-memory size? Other than, of course, that I have enough DRAM on the box. Is there anything else I should be mindful of?
Yeah, great question. So you do have to have enough, since the in-memory column stores we'll show you once we start it back up, does take memory out of the SGA, you do have to have enough memory in the SGA to allocate the column store. And we tend to, in our best practices presentations, we say, don't steal memory from, say, the buffer cache or the shared pool. So you really have to think of adding additional DRAM or additional memory to the SGA to accommodate the size of the column store. In this case, I don't really have anything else running in the database, so I'm going to take half of my SGA size and allocate it to the column store. But if you had a running database with actual applications, you could severely impact your workload or your the performance of your applications if all of a sudden you took away 200 gigabytes from an actively running database. You really need to think of adding additional memory. That's kind of the in-memory part of database and memory.
Okay, so it's coming out of my SGA, and just make sure I don't starve any of the other components. All right, good.
Exactly. My shutdown takes a little longer, but now we'll be able to start it up, and let's see what happens. So actually, the startup, once we allocate the column store, the database isn't unavailable. We don't have to do anything. We just allocate the memory as part of the SGA. We're seeing here this in-memory in-memory area of 200 gigabytes, but the database is up, running, available, and we haven't populated anything, but all of that happens in the background. So all you do is set the in-memory underscore size parameter, and the database acts just like it would if you didn't have it there, as far as startup, memory usage, all of those issues. So now we see that we have this in-memory area now allocated with 200 gigabytes. So that's actually how simple it is. That's literally all you have to do. What I was going to do, I have a few notes here so I don't forget what to show you. I wanted to show you, so how do you tell that it's allocated other than looking at startup, or maybe you do an show SGA? Wouldn't be data or Oracle database if we didn't have $v$ views, if we didn't have hints, we didn't have all of the normal statistics. So there is a $v$ view for you to basically select from to see how much memory you have allocated to the column store. So I'm a little leery that my formatting is going to be off here, but the view is actually in-memory underscore area. Since I can't talk and type at the same time, a little pause there. So actually what we see now, what's interesting about this is actually a multi-tenant database. So I actually have installed in there 2 PDBs, but you'll see that for each container ID, if you will, the size is the same. We have a 1 megabyte pool and a 64K pool. So the 1 megabyte pool would be the IMCUs or the actual columnar formatted data. We haven't used any of that because we haven't populated anything. And then the 64K pool is for metadata. And we see that each of the containers sees the same amount of memory. And since it's a $V view, it's the CDB or the root, well, actually, that's not, yeah, CDB root that actually has the memory. And we'll kind of go over a little bit about PDBs and talk about if we wanted to populate data between different PDBs. Actually, I had another query for you to actually show you the PDBs we have defined, which is why I always try to write this stuff down so I don't forget what to tell you guys. Oops. So there's also a V view, $V PDBs, where you can see what PDBs you have. I didn't format that very well, but we see that we have Cloud P1 and Cloud P2 are both PDBs, and so those are, we don't see it actually, oh yeah, the container name, and those are the container ID 3 and 4. And what I was going to actually do then was connect to, we'll use Cloud P1. So remember to go to the right user ID so we can actually populate some tables as well. Now, one other interesting thing about, whoops, show parameters. PDBs, and if you're not in a non-multi-tenant database, it's just as it always would be. It's just a single instance. You show SGA or show select from $V views will just show you the default instance. You don't have multiple PDBs or multiple instances running. But since Oracle's recommended installation now is 1 PDB, and then I have actually 2 PDBs, so I can show things like this. Notice that our in-memory underscore size parameter, now we're connected to the DBIM user ID under Cloud P1 or one of the PDBs, actually has the same in-memory size as what I set it to in the container database. Now you can actually reduce that size, but that size by default will be the entire column store. And so let's actually, what I had wanted to do was let's populate something. So we've configured the in-memory column store. That's literally all you have to do is set the in-memory underscore size parameter and recycle the database. So that's pretty simple. And then, well, it doesn't do us any good if we don't have any objects populated. So how do we populate an object? And we can do this. Let's see what tables we have. So I have our traditional star schema benchmark set up in this DBIM user ID. And so what we'll do is we'll populate the line order table. It's not very big, but populating a table, we can support tables, partitions, subpartitions, or materialized views. We can, it's as simple as an alter table command. So alter table line order. Got this, yep. In memory. So I took the defaults for all of the parameters. That's literally all you have to do. So with a default of priority of none, I'll actually select from that table to begin the population of the line order table. I could have set a priority, which would have said begin populating essentially immediately. That would be something you might do in a production system where if the database were to go down and come back up, you would certainly want those objects to be populated as soon as possible. So you might set a priority, and then that can control the priority then can control which objects will be populated first. We support critical, high, medium, and low, and then obviously the default, which is none. So let's go ahead and select from that table. But the database was open originally. It's still available. I'm able to select and do all of the normal commands or an application could run. And what happens is in the background, hopefully this will all work. Yep. We have these, see these Aura W processes at the top of our, this is just the top. So this command lets you see the processes in the Linux operating system and what's running. And we see that we have a whole bunch of these Aura W processes, and these fired up, they run asynchronously in the background, like log writer or database writer might be running, and they actually do the population of our table. And since I altered that table line order to be in memory, and I selected from it with, so it's now going to be populated. And so you see that all of these worker processes, I have actually a fairly big machine here. And so I have a whole bunch of worker processes set up. By default, you have the CPU count divided by 2. So you can do this on your laptop. I run this on a database on my laptops and sometimes do that for conferences. Or on your regular production machines, you obviously would have more resources. Now we see that all those worker processes are now gone. So we can assume, and let's see if it's true, that we populated all of those objects into the column store. Now I'm going to cheat and use a script I have. I'll show you what it does, so I don't have to try to type out the SQL query. But we see that our owner, DBIM, segment names line order, and we now, bytes not populated. Now that's a key attribute of the view. Let's look at that SQL real quick. So notice we selected from, I use $GV$IM segments. In this case, we're not rack, but we could just look at $V$IM segments. But notice I just queried a couple of the attributes of that $V$ view. And notice that we have bytes not populated is set to 0. That's really what you need to key in on to understand that the object's fully populated. Did you have a question, Maria?
I did.
Okay.
You can tell by the look of my face.
I did.
Now that you've got it populated, the question was actually about the size of the in-memory column store. And in a PDB, you mentioned there in a PDB CDB environment, the parameter is set at the CDB level and that all of the PDBs see that same size. And the question came in from Shri asking, is there any way that I can basically spread it across the PDB so everybody gets an equal share? Or can I do something else to make sure that one PDB doesn't steal everybody else's in-memory column store allocation? So can I manage basically the column store across the PDBs? And
the answer is yes. So you can set the in-memory size on each PDB to be less than the total amount of memory, and that way it'll be like an upper limit or a cap on each of the individual PDBs. So maybe our Cloud P1 PDB, I could have set it to 100 gigabytes, and then I could have set the PDB2 or the Cloud P2 that I showed you, I could have set that to 100 gigabytes, and then that way they don't interfere with each other. We can carve out the memory for each PDB. Now, an interesting side note to that is that you can actually over-allocate the memory or the in-memory size on a PDB. And the motivation there is, what if you were to, say, unplug one of the PDBs and you didn't want to have to restart the other PDB to take advantage of the memory that PDB that you unplugged was taking up. Now that becomes less of an issue in 12.2 because we also now support in 12.2 the ability to dynamically resize the column store and make it grow larger. So now there's less motivation than there was when we were on 12.102 to do that, so that you can actually give each PDB just the amount of column store that you want, but obviously you're limited by the total amount of memory that's been allocated in the container database.
Cool. Okay, so then I can limit by setting the in-memory parameter on a per PDB basis. So in fact, one of them could have 0, right? So that they don't use the column store at all if we wanted to. Okay, great.
Yep, absolutely.
I think that's it.
Okay, and so now we've literally populated our line order table into the column store. A little tongue twister there. Let's just, as a kind of a wrap up, we said we could look at the amount of memory we've allocated in $v in memory. So let's, I'm trying to talk and type at the same time. So now we see that we do have space used in our column store. So we still have our total of 200 gigabytes divided between the 1 meg and 64K pool. And we've used up, what is that, almost 40 gigabytes for the line order table.
Andy, is it true to say that if the object, the line order table, is 40 gigs on disk, it'll take 40 gigs of that 1 meg pool?
No, it's not. So actually, we didn't get much compression on our line order table, unless I'm not looking right. There's actually multiple levels of compression. Typically, we get anywhere from 2x to 20x compression rate. Actually, I know I forgot about that. So in my, so this is actually taken from a hands-on lab demo that we do. And so I've actually compressed the line order table with basic table compression. And I didn't think about the fact that that's actually why you notice the bytes, which is the size on disk, and the in-memory size are just about the same. And actually the trick there is that we already get, when we do on-disk compression, which is completely separate from in-memory compression, we already get about a 2x compression rate on the line order table. So it looks like we didn't get any compression. And I'll have to remember to, usually I highlight that with a script in the hands-on lab. For this purposes, though, we got tripped up in not realizing that we weren't going to actually see the compression. But very often, the default compression level, mem compress for query low, usually gives us anywhere from like a 2 to 4x compression rate. It is somewhat data dependent, but people usually see at least 2x compression. And then at the higher levels, like the 4 capacity options, we get a much better compression rate from 10 to 20x is very typical.
Okay, so as long as I don't have it compressed on disk, I should see it to be smaller in memory than it was on disk.
Right, but because that bytes field is just showing us what it is on disk, and since we don't, we don't try to guesstimate that if we decompressed it, it would be this size. We just see what's actually there.
Right. Okay.
So that's a little flub on my part, I guess, for this demo, but it usually works well when we're working on like laptops or virtual boxes where we need to consolidate as much data as possible and compress it. And of course, customers use advanced row compression and compression all the time. So it's good to know that all of that's very seamless. Compression on disk, compression in memory, even though it's different, it's fully supported, works seamlessly.
Cool.
And that's about all I had, actually, for the demo.